Hi, I'm Arjan. Today I'll walk you through building a powerful conversational AI assistant that helps users find concerts and book tickets using Rasa. We'll use a small hard-coded dataset and keep it simple. No external APIs, just logic. Now I want to go a bit further than just a getting started tutorial in this video and show you some of the more advanced capabilities of Rasa. So I'll start with an agent that already works, but it has some limitations. And then I'll show you how to improve it step by step, making it more flexible, reliable, and robust. Now if you want to check out the full project, there's a link to Git repository in the description. Here's what the agent project looks like. So as you can see, you already have a couple of files and folders here. There's a few interesting things here. Well, first we have the PyProject file, which we need for almost any Python project, where we have the name of the project, the Python version that we're using, the dependencies, which in this case is the Rasa Pro package. Also, there's a .env file. I have an example here where we add our Rasa license, and in this case this agent is also using OpenAI. So there's an OpenAI API key, and you can basically use your own licenses and keys here to run this project yourself. Then we have some files for configuration, settings for credentials. You can modify things as you want here. And then different types of endpoints, for example, the OpenAI model. And there are some other settings here that are actually also quite interesting to talk about that I'll come back to in a minute. Then we have various folders. For example, there's a domain folder where in this case, this is a concert agent. So we have information related to the concerts domain. I'll talk more about the contents of this file later. And there's some common shared context as well, like a chit chat, welcome message, things like that. Then we have data, which contains the flows. I'll talk about that in a minute as well. We have some default protections to not allow users to hack into the agent. And we have a couple of common patterns as well that you'll use in many agents. Then we also have an actions folder. This is actually the place where you connect your agent with code. For example, some external API, or you want to read something from a database, or things like that. And as you can see here, I have a hard-coded concert database, which just contains a few different concerts, in this case in October, that we can work with in this agent. And if you want to build this out fully, of course, you probably want to connect this to an actual database. And then to have access to this concert database, there is an action to find concerts. And that's a simple class that has a name and has a run method that gets the context of the agent. Like the domain, you can get data that the agent collected and so on. And then it's going to find concerts within these dates, format those results so the agent can work with it and return that as a result. So that's the overall setup of this project. Now, Rasa, there are several important concepts that you should know about. And the first is slot. Now, a slot is basically a piece of data that you keep track of in your interaction. For example, if we go back to the domain file here, you see that there's a bunch of slots that have been defined here. So this agent has slots to store the artist that you're looking for, to store the genre of music that you're looking for, a date range, starting date, ending date, matched concert. So not all of these are information that you collect from the user. Some of them are going to be filled in by actions or other elements of your agent. For example, if you go back to this find concerts action, you see that it creates a matching concerts list. And in the return statement of this action, this is actually set as a slot. So that maps back to this slot that we have right here, match concerts. So this is in essence a representation of all the data that the agent handles. Now, alongside slots, Rasa uses flows to define the logic of structured tasks, like finding a concert or booking a ticket. And you can see an example of such a flow right here. So we have a find concerts flow that relates to a number of slots, like the artist, the genre, and the start and end date, and has steps. So we collect these various things in this particular flow. Now you might wonder, why not just use a really big prompt and then let the LLM handle all of this? Well, this is actually all about certainty. Flows give you reliable, predictable automation without needing all sorts of complex prompt guardrails. So they don't particularly restrict the conversation. I mean, users can still change topics or correct themselves, but the assistant just stays on track better. Now, Rasa also supports RAG and MCP agents, but flows, they're really perfect for when you want this kind of predictable, reliable automation. So finally, if you go back to the concerts domain, you see that next to slots, there are also responses, things that the agent can say, like, are you looking for a specific artist? Or when would you like to go see a concert? Now, the agent is not going to say these things verbatim, but an LLM is used to make these responses more contextual. And this is actually controlled by settings. So like I mentioned, we have these settings here. If we go to the endpoints, you see that we have here a rephrase all setting. And that means that the agent is not going to say all these responses literally, but it's going to adapt them to the context. Now let's see the agent in action. First, I'm training the data. This also does some validation of the various domains and actions and slots. And now that the agent is trained, we can run Rasa inspect. That opens a simple web page where we can interact with this agent. And here you see what that looks like. Like I mentioned, flows in Rasa provide structure, but they don't restrict the conversation. For example, let's say that I want to go see a jazz concert. As expected, the current value of the genre slot is jazz, but now let's say I change my mind. There's no need to define all of this in the flow. The agent naturally responds and updates the slot value, as you can see right here. So as you can see, this agent can search for context, but the dialogue doesn't feel very natural. It's quite clunky. One reason for that is that artist and genre information is currently not taken into account in the concert search action. So as you can see, I indicate a genre here and an artist, but basically get back the whole list of concerts in October. So let's add a filter for artist and genre to the action. So the first thing that I'm going to do is I will retrieve the values of these slots, of the artist and genre slot. Currently, as you can see, there is a date match. So now we'll also add an artist and genre filter. And we're doing this for each of the concerts in the database of concerts. By the way, normally you wouldn't write all of this logic directly in the action. In a real setting, you should write the business logic somewhere else and then let your action call that code. For example, as an API call, where you pass the query parameters along. So let's save this. And now we're restarting the agent and see if it works better. And now you can see it actually filters by artist. As you can see, you have quite a bit of control in an action. You have access to all the important information from the conversation. And what I kind of secretly added here as well is that there's now a special any type of artist or genre, which is set by the agent if the user doesn't indicate a preference. And for artist, having an any type is really simple because an artist is basically a text slot, so that can contain the value any. But if you look at genre, that's slightly different. It's a categorical type. And that means we can indicate specific values. So if you want the user to also be able to have any type of genre, we need to add that value here. And we can even set that as an initial value. So by default, if the user doesn't indicate it, there is no particular preference. Now, having these categorical types is actually quite helpful because it makes matching more reliable and it ensures that your bot only uses genres that your backend or your API actually supports. For example, if a user asks for progressive new wave screamo, your API probably won't know what to do with that, and your assistant won't either. Now let's run the agent again and see what happens. So I'd still like to go for concert tickets. No artist. And as you can see on the left, we have the slots here. And there is artist, which is now set to any. And for genre, let's say I pick jazz. As you can see on the left here, we have the slots. There also now genre is set to jazz. And I'd still like to go in October. Now, as you can see, we get 2 jazz concerts in October. Another nice thing you can do with Rasa is add conditionals to flows. For example, the agent currently always asks for both artist and genre, but actually it makes sense that we only ask for one of those things. So if there's already a specific artist that the user has in mind, we don't need to ask for a genre and vice versa. And we can actually nicely capture this in a conditional. So let's open the YAML file containing the flows. And then what I'll do is that after collecting the artist, that we're going to specify what the next step is depending on a condition. So if the artist is any, then we're going to collect the genre. And otherwise, we're going to collect the dates. Also, an interesting thing to note here is that steps can have an ID, and then you can refer to these IDs in the flow. So in this case, there is a collect dates steps that has this particular ID, and you also see it specified right here. So let's run the agent one more time and see this in action. So as you can see, it now skips the genre collection because I already specified an artist. Now, if you want your agent to be robust, you also need to consider edge cases. You can also use conditionals for that. For example, let's say the user is looking for some artist, but there are actually no matching concerts. Then the agent should also respond something appropriately. So you can actually use the value of the matched concert slots to decide whether the agent should say that no matches were found. And you can do that after running the particular action that finds the concerts. And as you can see here, I'm also using a conditional. So if there are no match concerts, then we're going to utter that no matches have been found. Let's run the agent one more time to see how this works. Now in November, there were no concerts by Adele. But as you can see, the agent now also appropriately responds this. Before ending this video, I want to show you one more thing. A powerful extension of the capabilities of the agent is to let it adapt to the feedback that it gets from the user. For example, say that the user requested a certain genre of music, but doesn't like the concerts that were suggested. So here's an example of what you can do to then let the agent show the user something else. So in my flow, I've added now an extra step called exclude keywords, and this excludes keywords from concert search. For example, if the user rejects a suggested concert with phrases like anything else or show me something different, then it's going to extract keywords from those artists or mentioned artists that they don't want. And then of course you also need to add a slot for that so that you can keep track of the keywords that have been excluded. This also means that you need to add this functionality to the concert search action. So the first thing that you need to do is, of course, retrieve the value of the exclude keyword slots. And then the next thing you do is, before actually filtering the concerts, is to actually parse these excluded keywords. So what I'm doing here is simply turning it into a list, so it's a bit easier to work with in Python. And then what you can do after applying the filters and before appending the concert to the matching concert list is just to check that none of these keywords are mentioned there by looking at both the artist and the genre. Let's run the agent one more time. So now we have a list of concerts, but actually I don't really like Norah Jones. As you can see, the agent now excludes certain keywords and sends me a new list of matched concerts. So to recap, I just worked on a full-featured Rasa assistant that uses an LLM to extract inputs, can find matching concerts based on artist or genre, and that's a lot more robust than the initial version. Now feel free to extend this agent with more capabilities. You can use the same principles, slots, flows, actions, to also let the agent do other things like, for example, handle ticket reservations. In the Git repository, you can already find a basic implementation for this. So next to this find concerts action, this also contains a book ticket action that gets a selected concert name and email, and then can in principle integrate with a ticketing API. And of course, you also need a flow for that with the steps in order to help the users book the ticket. And of course, that also means a few extra slots like the name and the email address, and a few extra responses as well, like uttering that a booking is complete. So feel free to play around with this. And of course, you can extend this in many more ways. For example, you could have a real database, payments, reminders, or have the bot judge your music taste. Thanks for watching. To build your own Rasa agent, head over to rasa.com and sign up for the developer edition today. The link is also in the video description.